Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
And today we are going to start AC circuits. And I'm sure that slowly you're gaining confidence about the subject. Correct? Yes. So should we start the second unit now? Fine. So if you remember, when we discussed few basic terminologies, at the starting, we already saw what exactly is alternating current, isn't it? But quickly we will have a revision of that. So this is how AC signal is represented, and various terminologies are also given here. Like amplitude, generally amplitude is taken on y-axis, time is taken on x-axis, right? So whatever is the maximum value of that AC signal, that is a maximum amplitude. Okay. Now first of all, what do you mean by alternating current or AC signal? Well, AC signal is a signal whose amplitude continuously varies with respect to time, and it takes positive values as well as it takes negative value, and it repeats itself after a regular interval. Now, what is this regular interval called? This regular interval is called the time period of the signal, right? So, what is the time period of the signal? Time period is the time taken by the AC signal to complete one cycle, right? So, it is again represented. Now, peak to peak voltage is also represented. Now, peak to peak is the amplitude from negative peak to positive peak or positive peak to negative peak. Fine. So I'm sure now you are okay with all these terminologies. The same can be applied to current as well. The diagram, the waveform shows for voltage. The same can be applied for current as well. So let us see various forms of AC signals. Now here you can see that the first is the sine wave, right? Because the signal varies as a function of sine. So it can be represented as Vm sine theta or Im sine theta, right? The next is square, okay? The very next is triangular waveform. Fine, even triangular is an AC signal only because the amplitude is changing, right? And it is taking positive and negative value. The next type of waveform is sawtooth waveform. Now you can very well see that the signal resembles the the teeth of the saw, which is used to cut the wood. Correct. So the name is sawtooth signal. The name given to such type of signal is sawtooth signal. So all these signals are AC signals. Fine. So how exactly this AC signal is generated? If you must be having that query in your mind. Well, don't worry about it. We'll discuss it now. But let me tell you, the same thing is there in our syllabus in detail. So we are going to discuss it in detail later. Just in short, now we will be looking at it. Now you can see that you have a permanent magnet here, and you have a north pole and you have a south pole, right? So here is the north pole and here is the south pole. Okay. So what happens when you have a magnet? Magnetic lines of forces, yes, they start from north pole and they travel towards south pole. Correct? Do you remember that? We have studied that in 11th and 12th. Correct? Yes. So we have flux lines or magnetic lines of forces traveling from north pole to south pole. Fine. Okay. So what do we do is we have a conductor now, or we have a coil. Okay. It can be rectangular. Basically, it is wound on a core. That core is made up of iron, and we have a winding. So what we do is we simply wind the conductor on the core, and we keep this winding in between the permanent magnet. Fine. So if you see in this position where it is shown in the figure, the magnetic lines of forces pass through the conductor, isn't it? Because conductor has the boundary like this, and in between you do not have anything, right? So this center place is like it gives path to magnetic lines of forces. So all these magnetic lines of forces pass through the conductor. So at this point the current generated or the EMF generated is going to be 0. Fine. What we do is we start rotating this conductor in clockwise direction. Now all other points are shown in the figure, such as the slip rings and brushes, right? Their function is to collect the current and to give that current to further circuit, which is the load resistor R. Okay, we need not worry about that. Now what we are going to do is we are going to rotate this conductor. Okay, now in this process what happens? In this process the conductor cuts the magnetic line, correct? So now when it cuts the magnetic line, again in earlier classes you must have studied Faraday's law of electromagnetic induction, right? So that phenomenon takes place here. Now due to that phenomenon, what happens is whenever conductor cuts the magnetic lines of forces or flux, an EMF is induced inside it. So here also an EMF is produced. Fine. And that EMF changes with respect to the change as in with respect to the speed of the coil which is rotated here. So this EMF frequency will be proportional to the speed with which the conductor is rotated. Fine. Now because of this EMF, current is produced and the current starts flowing. Now this EMF or this current is nothing but our alternating current or alternating voltage. Fine. So this is how AC signal is generated. So the main phenomena which is responsible behind this is Faraday's law of electromagnetic induction. Okay. So you have an AC signal like this. Fine. So various minute details are displayed in this waveform now. Now you can represent this as A of t. Now I'll tell you where it is. See, here it is. I'm talking about this signal, this particular equation, A of t. Now when I write A of t, what does that mean? It means that the signal's amplitude is varying with respect to time. T is showing the function value that it is changing with respect to time. Okay, fine. Yes, so A of t means it can be voltage or it can be current. So A can be voltage or current, doesn't matter. Then this A of t is represented as Am sin omega t. So if I wish to write the same equation for current, it would be I of t is equal to Im sin omega t, or if I want to represent this as a voltage equation, I would write it as V of t is equal to Vm sin omega t. Fine. So this is how we represent it. Now you can see that this signal is starting. See, this signal is starting, right? This is 180 degree, then going down, and here it is 2 pi. Okay, so this is 0, this is pi, which is 180 degree, and this is 2 pi, which is 360 degree, right? Okay, so it is starting at 0, completing half cycle at 180 degree. Remember, 0 to pi or 0 to 180 degree is called half cycle. Fine. And it is completing one full cycle at 2 pi or 360 degrees. Fine. Now you can see that at what angle is it completing, is it attaining the maximum value? It is at pi by 2, positive value. And negative value the maximum amplitude, it is attaining it at 3 pi by 2. Fine, and various phase angles are shown here. So I hope this is clear to you. Okay. So now let us talk about various parameters, various values of AC signal. So we have a value called peak value. What do you mean by peak value? Peak value is the maximum value which is attained by an alternating quantity. It is represented by IM or VM. We have earlier seen that, isn't it, in the waveform? Yes. So the new terminology is the average value. Well, we are aware of the term called average value. I am talking about the AC signal. So what do you mean by that average value? Now average value is the arithmetic average of all the values of that particular alternating quantity over one cycle. So see, here you need to understand one point, that suppose a signal is a symmetrical signal. Now what do you mean by symmetrical signal? It means mirror image. Whatever positive values it has same negative values. Fine, so that is symmetrical signal. Okay, equal positive, equal negative. So whenever you have a symmetrical value, what is going to be the average value? Come on. It is going to be 0. Fine. Now this point is very important, right? So it has 0 average value. But average value, if it is taken from this point to this point, right? It means over one cycle. It has 0 average value, because it has equal positive and equal negative values. Fine. And root mean square. The third comes root mean square. Now root mean square, we will discuss it when the topic comes. Fine. So the same is written here, that mean value or average value of AC over one complete cycle is 0. So what do we do is, whenever we talk about a symmetrical value, we do not calculate average value for one cycle. Now what we do is, we calculate average value for half a cycle. That is from t is equal to 0 to t by 2, or from from omega is equal to 0 to 180 degrees, or 180 degrees to 360 degrees, depending on the waveform. Okay, so please do remember that if a signal is symmetrical, then we will be calculating the average for half cycle. If it is not symmetrical, which means if it is an unsymmetrical signal, then we will be calculating the average value for the whole cycle. And this is very important. Now how do we do that? I said that yes, we will be calculating, but how? So the equation for that is this. So average value is calculated by using this equation. We will be calculating the area of full or half cycle depending on whether it is an unsymmetrical signal or a symmetrical signal, and that area will be divided by the base length. Now what is the base length? If it is full cycle, then it is 2 pi. If it is half cycle, then it is going to be pi. Fine, that is going to be the base length. Okay. So the same is given here, that half cycle is taken for the symmetrical wave and full cycle is taken for unsymmetrical wave. Fine. Now please understand this very carefully, because this type of numerical which we are going to cover after this comes in examination, right? So this last line plays a very important role. Okay, so let us understand how to calculate the value of average value of any AC signal. So how do we represent an AC signal here? We represent current as I is equal to Im sin theta, where Im is the peak value or the maximum value. Fine. So for calculating average value, what did we see? We saw that it has to be the area, correct, of that signal divided by the base length. So how do we calculate the area? We integrate the signal. In order to get the area, we integrate the signal, correct? So integration 0 to pi I d theta is the area, and 1 by pi, that pi is going to be wavelength. Now why I am taking pi? Base length has to be 2 pi. Why I am taking the limiting condition of integration as 0 to pi? Why not 2 pi? Yes, please. I want an answer to this. Well, this is pi, or the limit is 0 to pi, because we are talking about a symmetrical signal. So we have to consider only half cycle. Okay? Yes. So we will put the value of I here, which is Im sin theta. Correct? So Im is a constant value because it is the maximum value. Fine. So what we will do is, we will take out Im out of that integration sign, and we will integrate sin theta d theta. So what is the integration of sin theta? Come on, we have studied that in 12th. Yes, it is minus cos theta, right? So here you have Im outside this, and divided by pi was already there, and sin theta integration was minus cos theta, limit 0 to pi. So we will be putting the value of pi and 0. So the equation becomes Im by pi minus cos pi minus, in bracket, minus cos 0. So what is the value of cos pi? It is minus 1, right? What is the value of cos 0? It is 1, and already minus sign is there, right? So you have this equation, minus minus gets cancelled, and finally both ones are added, and you get this to be Im upon pi. Inside the bracket we have 2. So basically this is the equation for average value, that is 2 Im by pi. This is very important, and please remember that we have calculated this average value for half cycle, because for full cycle it is going to be 0. The average value for full sine wave over one full cycle is going to be 0. Okay, please remember this equation, that I average is equal to 2 Im by pi. Now if I wish to write the same equation for V average, I can write V average is equal to 2 Vm by pi. Fine? Yes. So the next agenda is to calculate the average value of this waveform. Very interesting, isn't it? So we have got a new type of waveform. Correct? Yes. So do you feel that this is a symmetrical signal? No, it is not. Why? Because over half cycle the value is changing, and for the remaining half cycle the value is not changing. Correct? So what is going to be the base length of the signal? Yes, the base length of the signal is going to be, yes, 2 pi. Correct. Okay. So what I will write is, first I will understand few basic things. Sorry. Yes, sometimes it happens. Yes. Base length is going to be 2 pi. Yes. Next, what we are going to write is, we are going to understand which type of signal is this. So if you notice, till this point the signal is behaving like a sine wave, and from this to this it behaves as a zero value signal, right? So what we have to do is, we have to write the equation with respect to the interval. Okay, so I will write interval, okay, and I will write the equation. So what is going to be the interval? It is 0 to pi. So for an interval theta 0 to pi, my equation is, now let us understand what is my equation. So how do I write any signal? I write a signal as V is equal to Vm sin theta. But why I have written V? Why not I? Because the magnitude is given here. So it has to be V, right? Okay, fine. So V is equal to, now what is the value of Vm? Vm is the maximum value, which has been given here as 20 volts. So I will write 20. Okay, and sin theta. Yes. So it is 20 sin theta. Now for the value of theta greater than pi and less than 2 pi, what is V? V is 0. Okay, so this half work is done. See, if whenever we solve such numericals, no, the basic difficulty is writing this equation only. Once you have written this equation, no, half of the work is done. Fine. So let us calculate V average now. What is the formula for V average? We will be calculating the area of, now are we going to take full cycle or half cycle? We are going to take full cycle. Why? Because the signal is unsymmetrical signal upon the base length. Okay, fine. So this is going to be the area of full cycle, means we have to take it to be 0 to 2 pi. Okay, and then V, and then d theta. And what is my base length? It is 2 pi. Very good. The next step, V average is equal to, okay, so what we are going to do is, we are going to take 2 pi out of this. Okay, now integration 0 to 2 pi with d theta, but now we know that it does not have the same behavior from 0 to 2 pi. So we have divided our signal into two parts, isn't it? From 0 to pi and then pi to 2 pi. So what we are going to do is, we are going to write here two equations. So 0 to pi v d theta plus integration pi to 2 pi v d theta. Fine? Clear? Yes. So this becomes 1 upon 2 pi. Okay, integration 0 to pi, and what is the value of v here? It is 20, yes, sine theta d theta, right? And what is the second part? What is the value of second part? It is 0. Okay, yes. So now it is quite simple. Correct. So what is the next step? We are going to differentiate it, integrate it. I'm so sorry. Yes. So the next equation becomes, we'll take 20 outside it and we'll write upon 2 pi. So it becomes 0 to pi sine theta d theta. Now we have already integrated sine theta, isn't it? So we know how to do that. Yes, we very well know that. So it is 20, this is 20, 2 pi, and this comes out to be minus cos theta, and the limit is 0 to pi. Correct? So it is 20 upon 2 pi. We have minus cos pi minus, then again minus cos 0. So what is the value of this part? This part, the value is 2, right? Just before 2 minutes we solved it. So this comes out to be 20 upon 2 pi, and this comes out to be 2. Correct? So this 2 and this 2 gets cancelled. So that becomes 20 upon pi. So finally 20 upon 3.14. So what is my average value of the sine wave, half sine wave rather, a new type of sine wave? The average value for that particular signal comes out to be 20 upon 3.14, which comes out to be 6.366 volts. So this is the answer. Okay, so I hope you understood this. So we shall solve a new kind of numerical in the next lecture. See you until then. Bye.